In that case, I guess I can move on to one pixel attacks. This was an assignment for you to watch. Any questions about this? This paper is crazy. You can modify a single point in your image or a handful of points in your image, a handful of pixels, and then your neural network is going to make mistakes. Not only that, this is a black box attack. You don't even need to know your architecture. And the way that things are going to work, it's going to work through an evolutionary algorithm. You start with a set of parents. You keep generating children by mutating, and this is how you're going to mutate based on your parents. And then as soon as they mutate, you're going to be able to optimize. It's a combination of random search and evolution. I think it's a good time for me to stop. For those of you who want to leave, you can leave. For those of you who have questions, like the one that's already in the chat, you are more than welcome to stay. I'll be around. So there is a question about random erasing, which should somehow counteract this. Yes. So that's a data augmentation technique, random erasing. And this could be similar to this. Here you are, if you were trying to defend against this one pixel attack, you could keep erasing pixels like what you have from here, or you could erase multiple pixels, perhaps in a box. I'm not sure if anybody has studied that, the effect of random erasing on coming up with adversarial examples.
I would think the adversarial training with targets like this tend to be more efficient compared to things like random erasing in terms of regularization. Just in terms of it's targeting the change in the activation or the final prediction. You already know it's going to make a difference. I kind of feel like they're like basically like both a kind of regularization, but this one pixel attack is just like implemented to the extreme.
Yeah. So actually that's a good idea to try out. Try to see what is the effect of random erasing on one pixel attacks, or augmenting your data with one pixel attacked adversarial examples, and see what the differences are. Does it make your neural network more robust or not?
Yeah, that would be interesting to experiment.
Yeah, definitely. But this is crazy. The concept is crazy. Change one pixel, and then your neural network is going to make a mistake.
And just thinking, often in these classification problems, only part of your image, only so many pixels actually belong to the object that you're trying to see. And there are a lot of background noises in that image. Say if I take a passport picture, only the part that has my face on it is the part that makes sense. If the background is blue or yellow or black, that doesn't matter semantically. If something like this happens, if you change one pixel, I would think that should be a pixel at least on the image that makes sense. If something happens in the background and changes the final prediction, I think that means there's plenty of room for improvement for some kind of denoising to happen before you make that prediction.
Yeah, you can perhaps remove the background.
Yeah, is there a way to kind of leave out the back? I think that happens in layers after layers of convolution.
There are ways of doing that, but then even trying to remove the background is going to go through some convolutions. So even that one can be attacked. But the technology is there in terms of removing the background. It's we are using it already. When you're doing the Zoom meeting, you can change your background to whatever that you want.
True.
Okay, and it's doing it on a video on the fly online, and that's really fast. So the technology is there. But
yeah, maybe I'll do this one.
Even these pixels, some of them you're right, they are on the object of interest, but some of them are not. For instance, this pixel is being changed. This other pixel is in the background. This one is in the background. But we have to study this systematically. We have to say, was the pixel that the one pixel attack changed? Was it on the background or foreground? And you have to study that on your entire data set. How many images was it on the background? And how many of them was on the object itself?
Interesting. especially
Maybe.
that cat one.
Yeah. Maybe do you want to do that sometime?
Yeah, I might try to do this if I can get it implemented.
Yeah. I think the implementation for this should be, it's very easy. The algorithm is just this. Okay.
Okay, sounds good.
Yeah, perfect.
Thank you very much.
Yeah, sure. Have a good one.
Thank you. You too.
Bye.
Bye.